Hello students, I am Santhanalakshmi, Assistant Professor, Department of Computer Science, SDNB Vaishnav College. In this video, I am going to take Introduction to Data Structure. Learning outcomes. Upon completing this video, students will be able to learn the definition of data structure, learn the classification of data structure. Definition. Data structures are the building blocks of computer programming. Data structure is a particular way of organizing data in the computer so that it can be used efficiently. Students, look at the word efficiently here in data structure. Provide an efficient way of organizing the data, retrieving the data, managing and storing the data. An efficient data structure also uses minimum memory space and execution time to process the data structure. Here, the classification of data structure. There are two main categories of data structure. The first one is primitive data structure. The another type is non-primitive data structure. In primitive data structure, it contains fundamental data types such as integer, floating point numbers, characters, pointer, and these fundamental data types can hold a single value. For example, integer variable can hold only the integer values, floating point numbers, floating point type will store only the floating point numbers, then the pointer hold only the pointer values. The next one is non-primitive data structure that allows to store multiple data types, multiple type of values. And again, the non-primitive data structures are classified into linear and non-linear data structure. Linear data structure is a sequential data structure, and here the sequential means that all the elements in the memory are stored in a sequential manner. For example, elements stored after the second element would be the third element. The element stored after the third element would be the fourth element. We have different linear data structures holding the sequential values such as array, linked list, stack and queue. And the next point is non-linear data structure. Non-linear data structure is a kind of random type of data structure. The non-linear data structures are tree and graph or some of the examples. Under linear data structure, there are two types of linear data structure, that is static and dynamic data structure. Static data structure have a fixed values, fixed size and are allowed in memory during compile time, while dynamic data structure can grow and shrink in size during runtime. In static, there is a example array data structure. Under the dynamic data structure, we have linked list, stack, queue. Now, we'll go and see the type of linear data structure one by one. The first one is array. An array is a data structure that can hold the value of same type. It cannot contain the elements of different types like integer with character. For example, if the size of an array is 6, all 6 elements are integer data types. See the example here, ARR of 5, 5 is the size of the data, ARR is the name of the array, and it holds the values 2, 4, 8, 12 and 16. There are 5 values are there. So, here we can hold only the multiple item of same data type. And under that values, we have the array indexes, that is 0, 1, 2, 3, 4. By using the array indexes, we can able to retrieve the elements on the particular index. And next one is stack. Stack is a linear data structure which allows which follows the rule of LIFO, that is last in first out. All the operations on the stack are performed from the top of the stack, such as push and pop operation. The push operation is the process of inserting element into the stack, while the pop operation is the process of removing element from the stack. The stack data structure can be implemented by using either array or linked list. For example, think of a scenario where at a dinner party where there is a stack of plates. Plates are always added or removed from the top of the pile. In computer science, this concept is used for evaluating expressions and syntax parsing, scheduling algorithm and routing, etc. Here the push operation always at the top, push both the operation, push and pop both the operations or can be done at the top of the list, top of the stack. Next one is queue. Queue is a data structure that can be implemented by using array. The difference between the stack and queue data structure is that the element in the queue are inserted from the rear end, while the elements in the queue are removed from the front end. An excellent example of a queue in the real world is the line at a ticket counter where people are catered to according to their arrival sequence, and hence the person who arrives first is also the first to leave. Queue can be of many different kinds. Here is the example. To delete the element from the queue, we have to use the operation called dqueue, and in case of insertion of element at the end, we call the operation called enqueue. The next one under the linear data structure is linked list. It is a collection of nodes that are made up of two parts, that is data element and reference to the next node into the sequence. Linked list elements are not stored at the contiguous location. The elements are linked using pointers. See the example. The first node is called the head node. It has two parts. One is data part. The another part is called, it holds the address of the next node. So in each node we have two parts. And next one is non-linear data structure. Here elements are arranged in one to many or many to one and many to many dimensions. Example, tree, graph, table, etc. It is one type of non-primitive data structure. In non-linear data structure, data is not stored linear manner. The examples of non-linear data structures are tree and graph. The first one is tree. A tree data structure is an example of a non-linear data structure. It is a collection of nodes where each node consists of the data element. Every tree structure contains a single root node. In the tree, every child node is connected to the parent node. Every parent and child node has a parent-child node relationship. In the tree, nodes remaining at the last level are called leaf nodes and other nodes are called internal nodes. See the diagram? This is the structure of tree. The root node is A and the child of A is B and C. And every last node, that is last node of tree is called leaf node. And here we have, under a parent we have two children. The two children are called siblings. Then after that we have the another data structure is called graph. This is also the non-linear, under the non-linear data structure. Graph is a data structure that consists of a collection of nodes connected by edges. Graphs are used to represent relationship between objects and are widely used in computer science, mathematics and other fields. Graph can be used to model a wide variety of real world systems such as social network, transportation networks and computer networks. Graph, this is the example. Here we have, this is the undirected graph because we don't have any arrow to connect. So this is called the direct, we have the direct graph and also the undirected graph. This is one of the example for undirected graph. That's.
Thank you.
Thank you. Thank you girls for patient listening.